John, and this video is intended to show how a capacitor works. At the basic level, a capacitor is a device capable of storing electrical energy. How it does that gets a little more complicated. Basically, it's two plates that have a surface charge density that are opposite of each other that causes an electric field to occur between the two of them. That is where the potential energy is stored. Since the battery is a DC power supply, the electrons will travel in one direction. They will travel away from the negative terminal of the battery to the negative capacitor plate, where they'll cause a negative surface charge density. Because of this negative surface charge density, there will be an induced positive surface charge density on this opposing plate. The electrons from that plate will be pushed away and also drawn away by the battery along this conductor path and into the battery, where by means of chemical energy they will be moved to the other negative terminal, and the whole process will repeat. As you can see, the electron begins the simulation moving quite rapidly, but then begins to slow, and that is because the EMF of the battery becomes opposed to the electric field that's caused by the surface charge density, the negative surface charge density on the negative plate, and so the electrons are beginning to have to be forced onto that plate until it reaches an equilibrium point at which it is equal to the EMF of the battery. When the field of the capacitor becomes equivalent to that caused by the battery, electron flow stops. So the only way for the system to get out of equilibrium would be to remove the capacitor from the system and to discharge it. So that is essentially how a capacitor works. It's analogous to a spring in that capacitance is similar to the elasticity of the spring. Instead of storing potential energy in the spring mechanically, however, a capacitor stores its potential energy in the electric field. I hope this was able to clear up some of the conceptual issues you may or may not have had with capacitors, and I hope you enjoyed the video. Thank you.